Okay, in the vehicle, in this schematic representation of a car, so generally how we are measuring the acceleration. So there is an accelerometer sensor. So it is a electronic sensor which is used to measure the acceleration of the vehicle. Generally, we are using accelerometer sensor to measure the accelerations in the vehicles. Okay, so how is the working of the working principle of accelerometer sensor? So which convert acceleration into electrical signals so that the electrical signal can send it to electronic control unit after amplification. So that is the principle of accelerometer sensor. So generally we can classify three types of accelerometer. First one a capacitive accelerometer, second one piezoresistive accelerometer, third one piezoelectric accelerometer. So in the capacitive accelerometer, there will be a micro machined feature which produce some capacitance in accordance with the acceleration. So the change in capacitance is related to acceleration. Okay, so that is the measurement principle for a capacitive acceleration accelerometer. Then piezoelectric. So there will be a piezoelectric crystal which is mounted on the setup, and so which will give the output voltage corresponding to acceleration. Okay, that is, piezoelectric crystal during some uh, when we are applying some force or some pressure, then it will produce some voltage. A voltage is generated on the piezoelectric crystal during we are applying some force or a pressure. Okay, then third one is piezoresistive. So it is also a micro machined feature which gives resistance changes during acceleration. So in capacitive accelerometer, uh, there will be change in capacitance which is related to acceleration. In the piezoelectric accelerometer, we will measure, it will generate electrical signal corresponding to acceleration by from the piezoelectric crystal. Then piezo-resistive method, there will be a micro machined feature which gives the resistance. So this resistance value changes with the acceleration. So these are the three basic method for accelerometer sensor. There are many other methods also by using Hall effect, and another method is the by using magnetoresistance, etc. Okay, so today we are going to discuss capacitive accelerometer, piezoresistive accelerometer, piezoelectrical accelerometer, how it is working. So in this diagram you can see that there are fixed plates. Okay, this green color, 1 2 3 4 5 6, you can see here fixed plates. The another is reddish color. Okay, you can see here this is a mass. When the vehicle is accelerating, this reddish colored which will move, which can move. Okay, when this moving, the gap between these two plates changes. When the gap is changing, you can see by using this equation, C is equal to A epsilon 0 by D. It is the equation for capacitance of the parallel plate capacitor. So, this setup consists of a mass which is attached with the springs. When the vehicle accelerates, this mass will move in the opposite direction. This mass will move in the opposite direction when the vehicle accelerates. So, the distance between these two places will change. So when the distance between these two places changes, what will happen? D changes. So definitely the capacitor value, capacitance of the capacitor will change. When the when the separation between two plates is changing, definitely capacitance of capacitor changes. So this change in capacitance goes to, it will produce change in so by you measuring this capacitance value, we can measure the acceleration. That is the basic principle behind the a capacitive accelerometer. So these are the just three-axis accelerometer. This is XY sensor and it is Z sensor. Okay, it is same thing. It is a block diagram for the XYZ sensor. Okay, you can see here there is a Z minus, Z plus. There is a anchor here. So when the vehicle moves, it will change it. It will change the position. So there is a definitely there is a change in the gap. During the changing the gap, the capacitance value you can see here Z external acceleration. So when this moving up this word, this part is move downward. So there is a change in the plate distance. So it will change the capacitance of the capacitor sensor. Okay, so these are the basic principles behind the accelerometer sensor, the capacitive type. It is another block diagram for the capacitive acceleration sensor. You can see in this diagram here it is a rigid substrate and there is a bearing pin and this is a capacitive sensing element. When the vehicle moves, when the vehicle is accelerating, so this acceleration induces a load in this plate. So what will happen? This plate is moving, the separation between these two plates reduces. Okay, it is a one plate, it is another plate. So when where vehicle is accelerating, when the vehicle is accelerating, it will apply some load in this plate. So this is a movable blade. So this blade is moving, the gap reduces. When the gap reduces, the capacitor C is equal to A epsilon 0 by D. When the D changes, C will increase. Okay, so you can see this is a schematic representation of acceleration output voltage. Okay, when the acceleration increasing, we can get a output voltage like this. So it is another schematic representation of the working. It is when the vehicle is accelerating, it will form a mechanical deflection here. So it will change the capacitance value. So after the conditioning electronics, we will get a voltage output which is proportional to mechanical input. So this is the schematic representation of the capacitive acceleration sensor. It is also another diagram which represent the capacitive acceleration sensor. Okay, it is a 3D diagram. This is a base, it is a module, conditioning module, shell, and it is a bracket and a blade here, bearing pin here, substrate here. Okay, we already discussed the principle last slide. Next, piezo resistive accelerometer. So which has a stable structure. It has a stable structure which is made with a silicon chip which is created by micro machining and semiconductor production technology. So there is a mass and a beam on which a set of piezo resistors are created on a silicon chip. We are using piezo resistor. What is piezo resistor? So it will generate the signal. It will generate the signal. Okay, that is a piezo means when we apply some strain or stress, it will give the resistance. That is the principle of piezo resistor. So in this piezo resistive accelerometer, there will be a mass and a beam on which a set of piezo resistors are created on a silicon chip. So set of electrical bridged is formed which is by using V-stone bridge or okay, there are many type of electronic circuit to understand the these things. So we will use various like V-stone bridge network. In the V-stone bridge network, there will be four resistor. P by Q equal to R by S. You already know it. Okay. So we will form a set of electrical bridge circuit. So with the piezo resistor. So it will generate the signal, and which is proportional to the applied acceleration. So the piezo-resistive accelerometer is basically based on change in electrical resistance in a strain gauge sensors. So sensors with the conventional glued on strain gauge, which is we will use in MEMS technology. Okay, that is the basic principle of piezo-resistive accelerometer. So these are just diagrams of piezo-resistive. You can see in this diagram there is a 1, 2, 3, 4, 5, 6, 7, 8 resistor is connected here. Okay, one will be in the mode of okay. By using this, we can get a piezo-resistive accelerometer sensor. This is another diagram which form the piezo-resistive accelerometer sensor. X-axis, Y-axis, Z-axis. Here we can connect one. Here another thing. Okay, it is another. Okay, you can see here in this diagram. During acceleration, this mass is moving along this direction. So there is a resistance here. There is another piezo resistor here. So corresponding to this, the resistance value changes during the motion of this mass. Okay. Similarly, this case, when the vehicle is accelerating along the top direction, or when the vehicle is moving downward, you can see this is the this mass is moving upward. This mass moves upward. So corresponding to the change of this mass, it is a piezo resistor. It is also piezo resistor. So the piezo resistor will generate the resistance value, okay, which is proportional to the motion of this mass. So by calculating the values we are getting from here, we can calculate the acceleration. It is another piezo-resistive accelerometer block diagram here. This is a base plate here. It is a cantilever beam. This is a piezo resistor is connected here. You can see here piezo resistor is connected. This is a substrate. This is a movable part. When this is moving, some force is applied here. So in piezo resistance, resistance of the material changes due to force applied. So during the acceleration, some force is applied, some stress is applied on the piezo resistor. So corresponding to it, it will generate the resistance. So by variation of resistance value, there should be some change in voltage. So by using this voltage, we can understand the acceleration. So here in this diagram, it is another diagram for piezo-resistive accelerometer. Okay. Now third one, piezoelectric accelerometer. You can see in this diagram, there is a crystal here. You can see there is a crystal here, and one mass is attached here. So here measuring electrode. One electrode is here, another electrode is here. So there is a measuring electrode. This is the base. So during the acceleration, what will happen? During the acceleration, the mass make an impact on the electrode. Okay, so the crystal, this mass gives a force on the crystal. So during the when the mass is acting a force on the crystal, it will generate the it is a piezoelectric crystal, so it will generate the voltage. This crystal will produce electricity when a when this crystal is under physical stress. So when the vehicle accelerates, which is a force is acting on the mass, right? That is a pseudo force. Okay, so this pseudo force cause to deform the piezoelectric crystal structure. So which will create some voltage. Okay, by measuring that voltage, we can get the piezo we can get to calculate the acceleration of the vehicle. So by using this method, it is a schematic representation of the piezoelectric accelerometer. We can measure by using this equation: E is equal to GT MA by A. G is the voltage sensitivity, A is the acceleration, A and T are area and thickness of the crystal, M is the seismic mass. Or we can explain more simply, piezoelectric effect. Okay, that is a piezo ceramics or quartz which generate a charge output when subjected to a force. So this is an example for schematic representation of piezo disc. When we apply the force, when we apply some force here, it will generate this the Q. So Q is equal to D into F. Okay, D means it is a piezo constant, right? Q means charge, F is the force. So here we can say that Q is proportional to F. The charge generated, which is proportional to the applied force. Okay. So in this case, you can see seismic mass is placed on the top of the piezo ceramics. It is a piezo ceramics, and there is a seismic mass here. So when the vehicle is accelerating along this direction, so the seismic mass makes some force, pseudo force on the piezo ceramics or piezo crystal, so which will produce the charge. Okay, by measuring this charge, we can the output charge is proportional to acceleration. So it is the schematic representation of a piezoelectric accelerometer sensor design. Schematic representation. This is a base and this is a socket, and there is a post here. You can see this is a shape of the, it is a 2D figure of the three-dimensional. Okay, so this is the three-dimensional picture. So there is a, it is a inverted figure, right? No, it is a direct figure, and ring-shaped zero ceramics, right? There is a seismic mass is placing on the top of the piezoelectric crystal. It is a piezoelectric or piezo ceramics is placed here, right? This seismic mass is placed here. When during the acceleration, the seismic mass will make some force on the piezo ceramics, so it will generate the voltage. It will, there will be variation in the voltage. Okay, so by measuring this voltage, we can get the acceleration. So we can compare the advantages and the disadvantages of accelerometer sensor. So it is a simple to interface, it has high impedance, it offers high sensitivity, it has high frequency response, and it is available at a low cost due to advancement in MEMS technology. Then it uses built-in signal conditioning circuit to measure capacitance. So there are some disadvantages. Okay, in spite of these things, it is very useful to, there are a lot of advantages, right? So it is another picture of a MEMS accelerometer. Okay, thank you.